We know that the derivative of sine is cosine. But what about the derivative of arcsine? Arcsine is the inverse of sine. Well, this is climb time, and in today's video, we're going to look at the derivative of arcsine of x. Okay, so by definition, an inverse means that if you take f of g of x, actually, I'll go the other way. I'm going to take g of f of x, and I'll change my colors just to be kind of fancy here. So g of f of x, like this. Okay, you're going to get basically sine, and instead of x, we're going to put in arcsine, like this. And if we do that, by definition, this comes out to be x. And I'll use another color for that. So this comes out to be x. So by definition, when you compose a function with its inverse, it comes out to be x. And we could go the other way as well. We could take f of g of x, and that's going to equal the arcsine of, that's going to equal the arcsine, I missed my n, the arcsine of sine of x. So I'll go like this, put in sine of x there, put in g of x here, and that's going to equal x. So by definition, inverses sort of undo each other. And so when we compose them and we take the output of one function and we make it the input of the other, if you're taking a function as inverse, it comes out to be x. It doesn't matter which way you go, it'll come out to be x in either case. So we know the derivative of sine is cosine. What is the derivative of arcsine going to be? Well, it may not be obvious what this is going to be, but we're going to look at a, I think, fairly easy way to figure out what it's going to be. So let's say y is equal to the arcsine of x. So y fx, kind of the same thing. And what that means is, that means that x is equal to the sine of y. So let me show you how I get that. So if you take the sine of both sides, sine of y is equal to the sine of the arcsine of x. And these cancel each other out, just as we showed up here. And by definition, they're inverse of each other, so you get x. So sine of y is equal to x. So if we say y is equal to arcsine of x, by the way, another way to write this is sine to the negative 1 of x. These mean the exact same thing. Arcsine, arcsine. They both pronounce arcsine. It's just two different ways to write it. So if we say y is equal to arcsine of x, that means the sine of y is equal to x. These and these are basically synonymous statements. But the important thing to recognize here is that y is an angle. We only take sine of angles. So y is an angle. And so that means if it's an angle and sine is a trig function, which means it's a ratio of two sides where y is an angle, that means we can draw a triangle. So that's what we're going to do next. We're going to draw a right triangle, and y is an angle. Okay, so sine of y, and it's equal to x. X is the same thing as x over 1. And so sine is defined as opposite over hypotenuse. So that means the opposite side is x, and the hypotenuse is 1. So this is, when we say y is equal to arcsine of x, we're basically referring to a triangle that looks like this. Because y equals arcsine of x is the same thing as sine of y equaling x. And y is an angle. And it's also, sine of y is a ratio of two sides. And this ratio of two sides is x over 1. So that's what we mean when we say the arcsine of x. We're basically saying there's a little right triangle here. Y is an angle. X is a ratio of two sides. So it's x over 1. So now we could use the Pythagorean theorem to figure out the side we're missing. So you got a squared plus b squared equals c squared. I'm not going to do this one, but it comes out to be 1 minus x squared. And you can do it yourself to verify that's the case. Do a squared plus b squared equals c squared. Solve for b squared. You'll see it comes out to be square root of 1 minus x squared. So why is that useful? Well, we'll find out in just a second. Okay, so we have sine of y is equal to x. I think I'm going to change colors now. So I'm going to write that again over here. So sine of y is equal to x. And this we know to be true. It's basically the exact same thing as saying y equals arcsin of x. And what we want to do is we want to find the derivative. So I'm going to just put x on the left because we're used to having the thing we take the derivative of on the left. But what I want to point out here is when I take the derivative, I'm treating x like I used to treat y. So if I take the derivative of this side, instead of it being dy over dx like it was before, it's now dx over dy. Because now x is like my dependent variable and y is like my independent variable. And so the variables are kind of switched on us. So if I take the derivative of sine, I know it's cosine. But I just it's going to be dx over dy instead of dy over dx, because instead of a y being over here and an x being there, the x and y are kind of switched. And so therefore, you get dx over dy instead of dy over dx. But going back to our original equation, we're trying to find the derivative of y. And so the derivative of y is dy over dx. So to get the derivative of y, which is dy over dx, we have to reciprocate. So we take the reciprocal of both sides. And if you do that, dy over dx comes out to be 1 over the cosine of y. And that's what happens if you take the reciprocal of both sides. And then we get what we're looking for, dy over dx. dy over dx is the derivative of the original function. So f prime of x would be dy over dx, which is going to be 1 over cosine of y. But that's how we got it. We basically rewrote it as sine of y equals x. And then we found dx over dy, and then we just flipped both sides. And now we have dy over dx. Now, cosine of y, the reason why we need that triangle is we need to fill in for cosine of y. Cosine of y is going to be the adjacent over the hypotenuse. So putting the adjacent over the hypotenuse, we get 1 all over the square root of 1 minus x squared. It turns out that is, in fact, what the derivative of arcsin of x is. So if f of x is equal to arcsin of x, f prime of x is going to equal 1 over the square root of 1 minus x squared. And you can do this for all the trig functions. So I'm going to draw an arrow here so it's a little bit more obvious what's going on. But you can do this same process for all the trig functions. Figure out what your angle is. Well, your angle is always going to be y, but make a little triangle and figure out what the size will be based on where x is at, and then you figure out the rest of the sides. Then you can take the derivative, and after you take the derivative, you can have to reciprocate to get dy over dx instead of dx over dy, and then you can plug back in for your trig function, and you end up getting what the derivative is. Now, this is not obvious. It's not obvious that if f of x was arcsin of x, the derivative would end up being 1 over the square root of 1 minus x squared. It's not obvious at all, but it comes from the right triangle that connects them all together. But what you have to remember is f of x, which is like your y values, is actually an angle. And so based on that angle, it ends up giving us this relationship, this triangle, and which eventually turns into this derivative. Now, I do want to point this out real quick. One thing we talked about before when we talked about inverses and slopes is that when you have two functions, a function is inverse, their slopes will be reciprocals of each other. So here you can see the reciprocal. It's 1 all over, and the derivative of sine is cosine. So it's 1 all over the derivative of the function. So g of x is the inverse of f, and so the derivative of sine is cosine. They're reciprocals of each other because it's 1 all over cosine. And instead of an x there, we have a y. So maybe we could have predicted that without going to all this work, but nonetheless, you can see why it kind of makes sense as well. Anyway, that is the derivative of arcsin of x, and this is a technique that you can find it by using a little right triangle, and it will work for all of your arc trig functions.